Yes, welcome from my side. Paul did a fantastic pitch because he already said most of the pieces that I wanted to bring across this message. Because I'm one of the tech companies that are pushing IoT into the market, and we see BIM as a big enabler in it. And besides not being only from an IoT company and a tech company, I'm also basically from a smart city lab. So we basically working on the same stuff Paul was talking about, and we have just the same experience. And that's why we have in the end just the same realization. We need BIM. BIM is basically the key enabler for us to basically work and implement our technology in the field. And BIM is this basically more than just a building model. It is a smart city model, and it's basically a reference model for everything what you want to do in the IoT world. And that's not only meaning that there's an additional edge and an afterlife to BIM, it also means there's a huge value to BIM in the afterlife. And that's what I'm going to show you a little bit within this presentation. So I'm basically from the Smart City Research Lab, and we basically have about 100 researchers really working and focusing on smart city problems, starting from energy, water, to traffic, and to basically urban awareness. So we're trying to optimize and see the city as a place where we can try to basically link all the data elements together, and then basically getting a holistic view of the city and really understanding how it's operating to optimize it in the second step. And as you said in the end, BIM and buildings are a central element of the city. So that's basically where the concrete is and where we're all living in. So this is basically the key element. So why do we need BIM? So the obvious reason we all know that yeah, BIM is very good to data exchange between basically the life cycle of a building and to basically hand over the information from planning to design, construction to operations. So far so good. So of course, like you as basically stakeholders, you're involved into this process, and you say, yes, it's nice to basically to get a BIM model from an architect, and then I basically can work and kind of basically plan the whole delivery. And that's of course the obvious benefits in the BIM basically is to minimize this information loss between these handovers. And then in the end effect basically what you get is you have better understanding basically of the whole project. You have a better understanding before you build it, what you're going to build. And before it build it also means 3D, and 3D is not only something which allows you to better understand and do clash detection of how your building will really look like. It's also very important and very valuable in terms of visualization when you go to your client. So, and also the client is in the end not only the building owner, it will also be basically the building operator. And that's very important for a company like us. You will see that later. And of course, basically then it allows you to coordinate between all basically the different stakeholders involved in the project. And for large projects, particularly when you're planning a city, we're talking here about hundreds of stakeholders that are involved in this planning, and you need this sync model to even work together and to collaborate. Without this, you're not able to collaborate. And the big benefit is if you have a digital model, you can collaborate from all over the world. And that's particularly the piece also what Paul was highlighting. He's working in the end part of the time in China, and I think he likes Irish better than China. And let's basically see what the building life cycle really looks like. So let's rescale the time scale to what it really looks like. So the building phase and the planning phase, that's in the end just like 2 or 5 years. The operation phase of the building is 20, 30 years before you start first refurbishment, and then additional basically 3 life cycles at least. So, and if you think of BIM, at the moment you use BIM for this first life cycle. So, and yeah, of course, you just had this like, there is kinds of themes of value, but what about basically the remaining life cycle, these 30 years of operation, where is BIM there? And that's actually the point which is getting very interesting. Because let's have a look on software, how software actually is sold nowadays. You basically all recognize that because all basically the big software deployer changed their business model to software as a service. You're not going to buy a software anymore, you rent it, and in the end, basically that's a completely new bureau process, and the whole software world is going into this model. So, And the big benefit for the software companies is kind of they still own it. They have full control of it. The cloud is the key enabler, and the cloud is also the key enabler behind BIM. Because basically this collaboration is only basically now with the cloud is basically possible across the world and between all the different people. And the next thing, basically a big benefit of software as a service for a software company is it means a steady income. So because you rent it, you basically get income year over year. And then you now try to apply that to BIM. So let's think of these 30 years of BIM in operation as a business opportunity. So instead of basically just creating a BIM, handing it over to the building owner, and then he basically puts it in somewhere in the cave and never use it again. So think of this as a steady business income, because you are the creator of this information, you might be the owner of this information, and you might later on sell it to the basically the operators. And you might not sell it as basically as one tagged information. You might rent this information, also meaning that you have basically to maintain it, to update it. But that's actually where then basically the big value of BIM is created. Because if it is a living model that basically really reflects what the building is doing, then you can use it in the life cycle of the building for all the fancy stuff Paul was talking about. And that's basically the important thing, because you are the creator and the owner of this information, you are a central piece in this business model and in this business concept. So why IBM? So what IBM as a tech company, so why are we now basically so much about BIM? So we are not basically, we don't have design softwares. And we are not basically, that's not our business. So what we have a huge portfolio of software in the operation. So we do asset management, we do facility management, we do energy management. And every time we enter a building, we need information about this building. And this is actually a big problem for us, because our customers, they're not owning one building, they normally own multiple buildings, hundreds of buildings across the globe. And then basically this facility management, energy management, gets a huge problem, because with each building, you lack information. And when you would have a building information model, you could quickly enter a building, set it up in your facility and energy management system, and basically get this thing running within a month. And that's basically big value to the business, to the facility management business, and to the energy management business. And BIM is here the enabler for the whole basically process, which brings back the value to the BIM model. So one basically example that we basically explored is Gatwick Airport. So Gatwick Airport, they built a new terminal, and it took them 8 months to simply set up the asset management system. So they have so many assets in the new terminal, it took them 8 months. And this basically means 8 months, 5 people just entering data in a huge Excel sheet. And that's basically meaning in a huge COBie model. So, and you can basically imagine that's a very tiresome, very error-prone job. So it's not basically, you want to avoid that. You want to, in the end, you simply want to have a model where most of this information is already contained, and then you want to import that and avoid that. And this is not only because you want to avoid basically this work. It also is because if you have an airport terminal, every day that thing is not operating, you're losing lots of money. And an airport terminal is really making huge amounts of money. So it's not basically the cost that you have to pay the people, it's also the lost opportunity that you have in terms of income. So, and that's exactly basically what we can do in IBM. So we simply take a BIM model, and it allows us and import the whole information, whatever we find in this BIM model, into our asset and energy management systems, and basically set up the system and pre-configure the systems within basically what took us before 8 months. We now can do it in 2 hours. So, and that's basically in the end meaning huge amounts of value. So, and when you are the creator of a BIM model, of a good BIM model, that contains this information. And the funny thing is, during the designing the building, you're touching all that information. So you already have all that information. The only thing what you need to do, you have to put it in the BIM model. And then the companies later can use it. And the moment they can save time and money by importing this information, they will pay it back to you as the creator and owner of this information. And the second nice pieces, and we've shown that in basically Paul's presentation, is, of course, you're also getting a great visualization. And that's actually very important, because when you know operating huge assets and buildings, so then visualization is the key to understand how the whole system works. So, and particularly also when we relate the whole thing to IoT. So another example is basically here they build a medical center, and instead of basically importing in the same situation like in an airport, they have tons of assets in a hospital, and again basically they manually add all this information to the asset management system. In this case, they simply took a BIM model, imported the whole thing. They did what they normally do basically over months. They did that basically in half an hour. And we have several of these examples where BIM is really working and really as a big enabler. And the interesting piece here is we are not interested in the 3D piece of the model itself for this job. We are interested in the data contained in terms of assets which are in the 3D model. And that's actually in the end, don't think of BIM as just a nice visualization. It is way more. It is an information model. And the information is an important piece in this name. So we just had this question, so what do we do with all these legacy buildings? And of course, like most of our buildings are building stocks, and nowadays basically we're going to renovate more buildings, particularly like in the Western countries, then we're going to build new buildings. And particularly also IoT economy, we have this great shock, and yes, basically that's basically will be the future market. So how can we get basically all this information basically for our old building stock? That we can use it for facility management, that we can use it for our smart city projects. So, and in the end, we simply do what we also do in our digital life. When we got a printout, we put it on the scanner and we scan it. And we can do the same thing with a building. You go into a building and you scan it. And you even can scan big assets. Like what we're doing at the moment, we're working together with Curry Group, and they scan our data center. And they're creating basically a BIM model out of our data center such that we can then manage the data center as an asset within BIM. And that's basically, again, a huge value because a data center has tons of assets. So, and the same thing if you think of the future, scanning at the moment, you're using a laser scanner. Wait 5 years, and then you simply go in the building, and you take out your phone, and you just basically do tape a movie of the building, of a room, and then you can use that information to create the model. So you don't need very complex equipment. And of course, at the moment, I'm feeling a little bit sorry for Kirby Group because they also still have to do quite a lot of manual work to get that BIM model out of the laser scan. But processes are getting basically with the experience are getting better. And when you basically want to work and use this in the future, you should start early because you need to get this experience. That's also the piece of Paul. Paul basically with all his projects, he only can do that because he has the people that can do that. So, and think of this. If you of course you can wait until basically BIM is fully into the market, and then, yes, we do that also. So, but then you will be one of the last to enter it, and you will not be basically recognized as a leader and as an experienced company in it. And that's actually basically where you and them will lose business. So now let's think about smart buildings. And actually, I'm not working in smart buildings anymore. Smart buildings is something we had talking about smart buildings since the 90s. So we are now working in cognitive buildings, and you probably have seen that IBM is now all about cognitive. And but what does it cognitive actually mean? So let's have a look at what this means. The first thing is, and we heard that today already in several times in questions and the discussion, IoT. So, well, okay, IoT, we had put sensors in buildings in the past already, and in new buildings, and when you build it, it already contains hundreds and thousands of sensors. So IoT is not really new to the building and the construction world, which actually is good, because you are one of the leaders in the field. So, but what IoT will change is the amount of data and sensors that we have in the building and the city, and what we actually can do with it. Because in the past, actually, we put tons of sensors in the building, but we never made use of it. And that's actually a huge, basically, a left business value that we have to exploit and utilize. And again, BIM is a huge enabler to do this. Because all this data that is created basically by sensors, that's actually unstructured data. So basically in computer science, you normally differentiate between structured data and unstructured data. Structured data, that's basically what you normally have in a nice database, and it's already well structured, already well sorted, and you can quickly look up something, and you really already due to its structure, it's very easy to understand. So, and that's why basically all database systems don't work for your problems, because they're designed for structured data. And with IoT, we're getting tons of unstructured data. And unstructured data has a problem. Nobody was thinking about how can we structure it. It's just there. And you have to structure it before you actually can analyze it. That makes it very hard to analyze unstructured data. Now let's think in a building what kind of data we have there and what a BIM model is. A BIM model is a structured data model. So a BIM model enables us to take all this data, this unstructured data, and to structure it by utilizing BIM, because BIM contains all the context information that we need to say where a sensor is, what it is measuring, and what we actually can do with the data and what it means. And that's actually the key enabler why BIM is so important in a building and in a smart city context, because it provides you the structure. So how does it look like? So if you're talking of IoT and thousands of sensors, this actually means you also have to rethink the problem itself of what you actually can do with the sensor information. Because you cannot touch each sensor and integrate it into your analytics system. You simply have to take out the sensor out of the box, put it somewhere, activate it in, and then the data has to flow and has to be analyzed automatically. Because with thousands of sensors, you cannot set up this manually. You have to automate the whole process. And to automate the whole process, you again need all this context information. And that basically means location, the assets, the people around it, the organizations owning basically locations and assets. And that's the important information that you need to analyze it. We did an analysis of if you actually can use BIM together with UC Berkeley. And we basically went through 80 applications of IoT in buildings. And we compared, can we actually use BIM for it? And BIM actually is it is the best out of the approach that we compared. It's not yet there, because BIM at the moment is lacking lots of information about sensors, but it's very good in all this context information, meaning space, organization, and assets. So that's the strength of BIM. And we, as a tech company, we can put the sensor information into it. And that's basically how it will change, because with all this data that we're getting basically with IoT, in the early past, we simply had automated buildings. So we kind of were automating the main assets, the boilers, the chillers, the handling units, and that's it. Then we basically now have the smart building area, where we basically kind of analyze the main consumers. So we're adding smart meters to the buildings, and we're kind of better understanding how basically the building operates and what it does. In the cognitive buildings, You simply take all the data and analyze it. But as I said, to analyze it, you need this context. Otherwise, you cannot analyze all this data. That's why nobody is analyzing at the moment all the data that is already created by a building, because you simply don't know where the sensor is and what it basically is related to, and you need all this context information. And again, BIM here is the centerpiece. And this basically will lead to another change. So in the future, when we think of like the smart grid and basically building talking to each other, Paul was also referring to that. So this basically means a building is not a static thing anymore in the future. It will have to adapt. It will have to adapt to the smart grid. It will be basically itself creating energy through basically energy harvesting or regenerative energy elements somewhere in the facade, for example. So, and then you basically come up with the idea, of course, what can you do with when all the buildings are talking together and kind of basically trading energy and communicating and trying to optimize the operation as a community. Then you need a system that is very flexible, that can support that. So, and that basically also means from the analytic and operation side, the system itself needs to be cognitive. It needs to be able to learn what's going on. It needs to be able to learn, for example, what is going on in the energy market, what is going on in my neighborhood. And that's actually what the cognitive element in the future building will be, because the building will be understanding the environment, will be understanding the requirements, and will be understanding also what is actually going on inside the building through IoT and all the sensor information. So, and finally, BIM here is a huge enabler, and it's enabling insights. So, another thing is that we already also touched is the change in our interfaces. So at the moment, we're all working in front of computer screens. Then we basically are moving towards laptops. We are getting now tablets, and we have smartphones. And we have, think of this, all these elements, so our devices are getting smaller and smaller. And in the end, this will mean a maintenance person in the future, they will enter a building only with their smartphone. They will carry around a huge laptop. And you also, like when you're designing a building, you will not do that on a huge desktop machine. You might simply do that on a tablet. You simply take out a pen, you sketch up the building, and then from this, you basically use the tablet as your primary interface. And the problem actually is that on the one hand, our work is getting more complex, our models are getting more complex, and with IoT, we're getting more and more of data, but our devices are getting smaller and smaller. And with these smaller devices, also the interaction is changing. We're not going to have a keyboard with a tablet in the future. And also our computer will not have a keyboard anymore. So we will simply use a tablet. And the other thing is like with a HoloLens, or with a basically virtual reality like the Oculus Rift, you will be able, doing design already, to enter your virtual environment and the virtual model that you're creating. And this allows you completely to rethink how you're actually designing a building. So you will end up with something what we call in software technology an agile design. You simply start with the first scratch, and then you basically go into it, you test it out, and then you're basically redoing it over and over again. And with the 3D model, you're actually seeing what you're doing. So, and the interesting thing is now, when we have this 3D model, one thing what we're doing is, for example, simply understanding how people are moving and behaving in a building. So, for example, if you enter an airport, normally all of us are using the Wi-Fi system. So, what you might not have recognized is, by using the Wi-Fi system, the airport is able to very nicely track you where you go. So, and let me tell you, they're doing that. They're very well understanding basically where you spend your time on the airport and how you move through the airport. And they're utilizing this information to optimize the airport operation, to optimize to which gate you want to go, and to optimize basically the whole layout of an airport. And they already can take this information when they're then planning a new terminal, because they actually take what they learned and put it into their new design. And the same thing you do basically also with, you can do with shopping centers as well as with office buildings. Space planning. You're not doing space planning in basically based on what you, on the design documents. You simply measure what's going on in the building, and then you can really optimize your space usage. So we have, relation to this, we actually have 2 European projects related to that. The Tribut project will also is also investigating on what you can actually do with energy simulation and how you basically can optimize and basically utilize energy simulation during building operation and utilize the data that you get out of the data to optimize your building simulation model. So this is actually also like a next nice thing that you can do when you link all these different elements together. And again, the center element here is a BIM model. You need to have a model of your building. The next thing is basically then concept visualization. So what actually you can do with this 3D model is not just a nice model that's looking kind of brilliantly. It's simply the way how we see the world. So it's not, of course, each of us basically know how to interpret a 2D plan. But do one thing, take a 2D map, go into a third world country and ask somebody on the street to interpret this 2D map and tell you where he's standing in a building. He would not be able to do that because he never learned how to basically map his experience from the 3D world into a 2D plan. And that's what we all have learned. That's why we have this skill. But the problem actually is we learned this abstraction. With the 3D model, we don't need this abstraction anymore. We simply have the model of the reality that we actually see and that we experience. That's why it's very important to have basically 3D models, because it allows you to very easy interpretation of your environment. And when you now combine that with IoT, that's what we do. We have about 3,000 sensors in our building, and truth be told, we have too much data to analyze. So, and we have too much data to visualize. Of course, nowadays, when you look at a BMS, you have a nice graph of your energy consumption. You can look at the temperature sensor, and you again get a nice plot. That's not going to work anymore when you have 3,000 sensors. You cannot go through 3,000 sensors. You simply want to see them all together. And that's basically what we are exploring and where we utilizing, again, 3D models. So we simply take this 3D model and then automatically we're adding all the sensors and all the sensor information. And you see that here we're creating different heat map layers where you see the temperature distribution, the relationship to basically the set points, the relationship to the occupancy in the space, and you're getting basically all this information on one screen, and you can easily see where your problems are. For example, where it's too cold or too hot in your building. Yeah, I'm nearly finished. So another thing is basically when we think of all this virtual reality, augmented reality stuff, and I really want to work into this because it's just fun to work with this. But it's also impressive because it completely allows you to explore the IoT world in a different way. Because and this thing actually is running on a web browser. So I can take out my smartphone, I put it in a Google Cardboard, and a Google Cardboard costs $2. So we're not talking about a hugely expensive device. We're talking about a card box. You put in your phone, and then you can go around and experience virtual reality. So, and then actually with the same, we're using the same model that we use in the other view, no modification, and now we actually see in 3D, we can walk through the building, you see where all the sensors are, you see basically all the values, and you really have this 3D feedback of your environment. Next thing is data access. Instead of basically looking up the sensor somewhere in the BMS, you simply point your phone to the sensor and you get the value back. And that's actually not only working with sensor values, actually it's working with assets. And that's basically, again, where BIM comes into play. Because you simply want to enter a building and you have somewhere a fan coil unit in the ceiling, and truth be told, I don't know the numbers of the fan coil units, and I don't want to know. I simply want to basically point my phone to the fan coil unit and directly see how it is basically how it is mounted behind the ceiling and what are all the values related to the fan coil units. And that's how it has to work. And again, BIM is here the centerpiece because it provides you all the information where I'm currently located at, what I'm looking at, and what's behind the ceiling. And that's actually also the closing slide of my talk. I'm already getting here time announcements. I hope you still have some time for questions.
Thank you. Has anybody anything particular they'd like to ask Joern? There's some question over here.
Yes, Joern, just on that point of augmented reality, to what extent do you think that GPS-enabled augmented reality will mean that people will visualize buildings in the actual location, itself, and that might actually potentially be a substitute even for the excitement around physical 3D models, that in the future will be much more in situ, and that's around the corner. What do you think?
So if you ask me, that's how it will be. So come on, in the end, what you want to do is you want to go to a building site with a client, and you simply basically give him a tablet instead of showing him somewhere on the street. Of course, you're creating nice views of the building and all that stuff, but he only sees a 2D thing. But think you take out your tablet, you're pointing it on the space where the building will be, and he actually sees the thing. And instead of using a tablet, you give him basically a Google Cardboard or a HoloLens, for example, and he sees the whole thing standing there. Like basically what Paul was saying, that's a completely new way of selling. This customer will sign directly if you have done a great design. So here, there will no discussion about it anymore, because he actually seeing what he's buying.
Anyone else have a question at this stage?